Welcome to the Explainer. Today, we're diving into a really cool AI methodology from the world of reinforcement learning. It's a technique that, get this, teaches an algorithm how to learn from stuff that never even happened. It's about teaching AI how to daydream and then actually use those daydreams to get smarter.
So, how in the world do you do that? Well, here's our plan. First, we're going to look at the core problem that makes this so tricky. Then, we'll see how the researchers built a what-if machine to generate these daydreams. And of course, we'll wrap up by asking the big question, does this thing actually work? Let's get into it.
Okay, so let's start with the fundamental challenge here. This is a big deal in reinforcement learning. You know, the field of AI that's all about learning from trial and error, kind of like how we do.
And that leads to this question, which, yeah, it sounds a little bit like a riddle, right? But it's the absolute central idea behind this algorithm they call Counterfactual Experience Augmentation, or CEA. It all comes down to this. How can an AI learn about what would have happened if it had made a different choice?
And here's why that's so important. These algorithms have a major blind spot, and it's called the out-of-distribution problem. Basically, they can only learn from the data they've actually gathered by doing things. And that leaves these huge, massive gaps in their understanding of the world, just a vast, empty space of possibilities they know literally nothing about.
So, to tackle this problem, the researchers turned to a really powerful idea from a totally different field, causal inference. They asked, what if the AI could just imagine the results of the actions it didn't take? What if it could fill in those blank spots all by itself?
This whole process has a name. It's called counterfactual inference, and it's really the engine that drives this entire method. I mean, it's the exact same kind of thinking we do all the time when we wonder, what if I had taken that other job? Or what would have happened if I turned left instead of right back there?
Think about it like this. Imagine an agent trying to find treasure. It makes a few real moves and sees what happens. Now, from that real experience, it starts to build what the paper calls an inference ability. This lets it predict where it would have ended up if it had made a different choice, all without having to actually take that step and risk it.
Now, for any of this what-if magic to work, the system has to make one key assumption. It's called Bisimulation, and it sounds complicated, but all it really means is that sometimes two totally different paths can lead to the exact same place. You know, whether you take the highway or the back roads, you can still wind up at the same coffee shop. This simple idea is absolutely critical for what comes next.
So let's get into the first big piece of the machinery here. Let's see how they actually built this imagination for the AI. This is where the engineering gets really, really clever.
What they did was create a special kind of neural network, and they call it the State Transition Autoencoder, or STA for short. Honestly, you can just think of the STA as the heart of this whole what-if machine. It's the part that actually generates the daydreams. And how it works is just so cool when you break it down. First, the STA takes a real memory, like say I moved from point A to point B. Then, it squishes that memory down into its most basic essential features. Next, it takes that essence and mashes it up with a hypothetical action. Something like, okay, but what if I had tried to go left instead? And then, boom, it generates a brand new, totally plausible, imagined outcome from that mix.
Okay, so the STA can imagine all these different futures. But with an almost infinite number of what-if actions it could try, which daydreams should it actually focus on, right? It can't possibly explore every single one.
I mean, just picking actions at random would be incredibly inefficient, a total waste of time. The goal isn't just to daydream, it's to daydream productively. The AI has to choose hypothetical actions that are going to teach it the most, the ones that explore the biggest, emptiest gaps in its knowledge.
So to guide its own imagination, the system has to keep asking itself this really important question. Okay, based on what I already know, where are the biggest holes in my understanding, and which daydreams are going to help me fill them in? And the solution they came up with is super smart. It's a technique called maximum entropy sampling. So instead of picking at random, this method intelligently finds and samples new actions that are as different as possible from everything the AI already knows. This makes sure that every single daydream is as informative as it can possibly be.
We are almost there. At this point, the AI has an imagined action and a predicted outcome, but we are missing one critical piece of the puzzle to make any of this useful for actual learning.
And that missing piece is the reward. For an AI to learn anything, it needs to know if an outcome was good or bad. But how on earth do you assign a score, a reward value, to a daydream? This was the last big hurdle they had to figure out. Well, the solution is just elegantly simple, and it takes us right back to that bisimulation idea. They call it the closest transition pair method. So the AI takes its imagined outcome. Let's say it dreams it ended up at state B. It then just searches through its real memories for any time it actually landed at or near state B. It finds one, sees the real reward it got was +10, and it just borrows it.
And just like that, the AI has created a complete, plausible, and totally useful piece of data entirely from its own imagination. This brand new synthetic memory gets added to its experience bank, giving it a much richer dataset to learn from, all without taking a single extra step in the real world.
So this all sounds fantastic in theory, right? Building an imagination for an AI is a super cool idea, but does it actually work? Does tacking on these manufactured daydreams to an AI's memory really help it learn better and faster in practice?
Well, the results are pretty darn telling. In the really complex dynamic environments like the highway driving game or the lunar lander task, the CEA algorithm just crushed the standard models. What's interesting, though, is that it did struggle a bit in the simpler pendulum task, and that suggests this kind of complex reasoning really shines when the problem itself is complex.
So, what's the big takeaway from all this? It's that teaching an AI to think about what might have been is a genuinely powerful way to solve that out-of-distribution problem we started with. It makes the AI way more data efficient, letting it learn a whole lot more from a lot less real-world experience. And that leaves us with a pretty fascinating thought to end on. As we build AIs that can learn not just from what is, but also from what could be, we really have to wonder, what are the true limits of an artificial imagination?